1.2 Compound Inequalities and Interval Notation. Compound sentences, which are also compound inequalities in math, may take on the form such as 4 less than x, which is also less than 10. Or they may look like, which as you're going to see, x is greater than negative 90, or x is less than 100. Another example is if they use the symbol which means or, which we're going to discuss in a minute. X is less than 7, or x is less than 20. And of course they can also use the other symbol for and. Okay, there are two types of compound inequalities. The first type that we're going to discuss is called a conjunction. Conjunctions are formed by using this symbol. So I'm sure if you've already looked, and I've seen some of you message me, I'm sure if you've already looked, you've seen this symbol, upside down looking U. And so it uses the word and the symbol is U. How you determine solutions to conjunctions is you look at the set of numbers that belongs to all solution sets you're discussing. So it will belong to all of them. The solution is a set that belongs to all. More than likely, you're going to be looking at 2 different solutions at one time. Sometimes we can look at 3 or 4, really infinitely many. Examples of conjunctions, or if I've got all the numbers belonging to from set 3 to 7, and I'm going to find where they overlap with the numbers that belong from 4 to 6. And recall that parentheses means you don't actually include that number. So this is considered to be the numbers that are all between 3 and 7, which definitely include 3.5, 4.29, things like that. And this set of numbers are all the numbers in between 4 and 6, but they don't include 4 and 6. So as we're going to see in a minute, we're going to be actually taking both of these sets of numbers or solution sets and combining them into one. Okay, another type of conjunction you may see, this is a very common one that you usually see. Like if I've got x minus 2 is less than 5 but less than 20. It's a sandwich or compound inequality put together. So in this case, to solve these later on, you would actually split this up. You would use what's in the middle, which is x minus 2, and you would create one inequality with the left part, and you would join it with and or the symbol that also means and. X minus 2, take the middle part and make an inequality with the right side. So then you would carry on further. So we're going to be solving inequalities like this, except for we're going to have multiple at one time. So the first thing we need to do is go over how you take 2 or more solution sets and make them into one using conjunctions and disjunctions. A disjunction is formed by using the word or. So here we have the word and that uses, or that is for conjunction. Disjunction uses the word or the symbol U. It looks like a U. So when you see this symbol, this also means or. the solution. So let's say that I've got some examples of disjunctions, or x is greater than or equal to -9, or x is less than or equal to 1/4. That's an example of a disjunction. Also, another example of a disjunction would be if I've got the solution set of numbers 1, 2, 3, and hello? And I've also going to join that with solution set. Hey.
Your network, are you having any issues right now?
Not right now.
Okay. Well, what's it been like?
It's been good except for the one day last Friday.
All right.
When it was out.
Email.
You're very welcome. So 1, 2, 3 for this solution set, and we can also join it with the solution set 4, 5, and 6. When you are looking, when you have and or that symbol, you're looking to actually find the set of numbers that belong to all. So you're looking for where all the solutions intersect or overlap. When you're dealing with disjunctions, you're looking to union or marry or join all solutions together. So if we were actually going to go further and write this as a final solution, you would actually put 1, 2, 3 together with 4, 5, 6 to make that final solution set. So hopefully it will make more sense to you in a minute as we do some. So,
Keep in there, Kelsey. Are you recording?
yeah. No, that's fine. I'll be done in a minute. So U for union, or that means the same thing. So when we see this, we're going to join our marry solutions. All right, and I just wanted you to remember that, so I wrote that down again. Intersect is where we're going to do. That's when you find out where both solutions intersect. When you see this or and, you find out where both solutions, or you join all solutions if you see this or. Okay, so the first thing we're going to do before we actually start solving some of those lengthy compound inequalities, we're going to practice writing solutions in interval notation. So I've got these numbers 1 through 4. I took these from your homework set. For the solution set, write your answers in interval notation. In number 1, you have this set of numbers 2, 4, 6, 8. Set of numbers 1, 3, 5, and 8. Notice they have in between them the conjunction symbol, or and. Recall, I said when you have and or conjunction, you are finding out where they intersect. So what you need to do here is find out what number is common to both sets. In this case, the only number that both sets have is 8. So I just want to find out where do they intersect, what numbers are in both of them. 8. In number 2, you have the numbers that belong to the even integers and the numbers that are the odd integers. If you'll recall, of course, our even integers just mean all the whole numbers, and they can be negative or positive. And 0 is also considered to be an integer. So you can have -4, -100, 100, 1000, all of those are integers. Even integers, of course, are like -2, 0, 2, 4, 6, 8, so on. The odd integers, of course, are like -1, 1, 3, all of those. If we are joining, that's what this is. Notice you're taking all the even integers, and this means that we are going to join them together with the odd integers. So you're finding out what numbers would belong in either set. Your final answer is all integers. If you take the even integers and you marry them or join them to the odd integers, then you get all integers. Now this is a stretch for your brain. If this was and, if I said even integers and odd integers, and I ask you to find the final solution set, you would be finding the solution set of numbers that belonged in both of them. So if I was asking you to find out where the even integers intersect with the odd integers, that would be no solution. Okay, number 3. This is a different way of showing you, but I'm trying to show you every way that you might see your solutions. In number 3, all right, when we get here, when they are written in inequality form, I always like to put them on a number line. It's okay. Okay.
I found him. I talked to him. He's holding it.
Okay, so what I will do, in this case, my two values are 10 and 4. So I'll just make a spot for 4, make a spot for 10. You don't have to, I mean, you can definitely make it very accurate and label all tick marks if you want to, but this is just a rough sketch to help me write these two solution sets using this compound notation, in other words. So what I'm trying to do, and I like to use different colors for this as well. So let's focus on x being less than or equal to 10. I will write that solution set on the number line, or draw it rather. So I'm going to put a closed total at 10 because it's got the equality part. And we're talking about all the numbers are less than or equal to 10. So you would shade that solution set to the left. The second part, x being greater than 4, you would have an open hole at 4, and of course shaded to your right. This, and recall what that means, I'm finding out where they intersect. So if you'll notice, the only place here where these two solutions intersect is from 4 to 10. Notice that's the only part in this whole drawing where you have both green and pink. So from this point to that point. And the way you write that in interval notation, you see what the farthest left value is, where they intersect, and it's at 4. But be careful, because notice that 4 is not included on both. 4 is open here. I'm only wanting to find out where they intersect. So I'm going to say parenthesis 4. And notice that they are both closed in at 10. 10 is on this solution set. 10 is also on that solution set. So we put a bracket. And that is your final answer. So once again, draw both solution sets or sketch them on a number line. I would do one above, one below. And then see if you've got and or. And you're finding out where they overlap. Or would be joining all of them together, which you're going to see in a minute. Okay, number 4. This is a compound inequality, which we discussed a minute ago. And you want to actually rewrite this we always rewrite these type using and. 6 greater than x, and x greater than or equal to -3. So take the middle, write an inequality with the left, take the middle, write an inequality with the right side. Be very careful with these. When the variable occurs to the right of the inequality symbol, I see students make frequent mistakes. I would actually flip this one around. Notice that the arrow is pointing to x. So this is actually x less than 6 and x greater than or equal to -3. Let's sketch it on a number line to find our final solution. So x less than 6. So make our numbers at -3 and 6. X less than 6 is going to be an open hole at 6. It's going to be to the left. Then you will put a shaded in hole at -3. So it gets shaded in hole and it's going to be all the way to the right. And once again, we're only finding out where do they intersect because we're using and. So notice that the only place where these two solution sets start overlapping is from -3, and it is shaded on both of them, all the way to 6, and 6 is open here. So it gets a parenthesis. When you're using and, the numbers have to be included on both solutions or all solutions for it to get the bracket. Okay, number 5. This one gets a little bit more difficult. These solution sets are already given to you in interval notation. Notice that you have this pair is in parentheses on its own. So you kind of have to treat this like order of operations and do what's inside grouping first. So we need to figure out this solution set. Then we're going to take it and join with this solution. So the first step, let's look at 3, 7 intersected with 1, 5. Okay, so what you want to do in this case, write all of your numbers here on the number line. Then let's focus on the solution set for 3, 7. You're saying that you're including every number from 3, but 3 is got a parenthesis, so we use an open hole, to 7. And 7 also gets an open hole because it has a parenthesis as well, meaning that those values are not included, but it approaches them. Okay, then let's look at solution set 1, 5. So in all these problems, you really just have to take it piece by piece, and then at the end, look at the final solution. So from 1 to 5, it starts at 1, and then goes to 5, starts at 1, don't include 1, goes to 5. Now for this part, this was also and, so you're going to find out where they intersect. Notice the only place that they overlap is here. Here from 3 to 5. 3 is included on this piece, but it's not here. So we got 3. And then 5 is included on this piece, but not here. So from 3 to 5 is the only place where these two solutions intersect or overlap. But we're not finished. That was just this part. Now we have to bring this down. We've got to join that piece with this solution set from 1 to 11. Once again, draw a number line. Label numbers 1, 3, 5, 11. Okay, now let's plot the solution set from 3 to 5. So it starts at 3, goes to 5, and they get open holes. Solution set 1 to 11 starts at 1, it gets a shaded in hole, goes to 11, which is open. Now, in this case, we are marrying both sets. So what you're going to do when you have or a union, you want to see the farthest left that any piece goes. So notice that either one of these is going left to 1. And then any piece, you see how far either piece goes. So this piece stops at 5, but this part of the graph picks it up and keeps carrying on to 11. And 11's open. So you're joining, so what we did is we just joined both solution sets, which if you'll notice, this solution set overtakes this one anyway. All right, number 6. Once again, sketch it on a number line to help you. So -7 and 6. This solution set, open hole at -7. It's going to the right forever. This solution set would be an open hole at 6. It is also going to the right forever. And you are joining. This is an or. So we are joining both solution sets. Joining or union, marry, whatever you want to call it. And so we see how far to the left either piece goes. It goes to the left, it's -7. And then it's going right, right, right. Then this piece, they both actually pick up and go to the right forever. Okay, next, we're going to look at solving compound inequalities and sentences and the steps. Okay, number 1. So when we begin solving inequalities that look like this, and you're going to be so happy to know this, our answers will look similar to what we just did. So now we're actually adding on a lot more steps. These problems do require a good bit of work, so make sure you show your work. Step number 1, to help you keep these problems in order, make yourself focus on one part at a time. In this first part, solve each inequality part and get its individual solution. Worry about what's in between them till the very end. So I'm going to worry about this symbol and this symbol till the end. You don't have to do this, but to help you visually see, you can plot each solution on a number line. Once you've solved each of your inequalities, go back and look at the symbol that was between them to to help you determine if you're going to find where all the solution sets intersect, or if you're going to join all solution sets together and write your final answer based on what you conclude. Number 7. Solve the following compound sentences. Write your final answer in interval notation. And number 7, this is a compound sentence. You have one part in the middle that is shared by the left and right parts. So recall I told you when you see this, rewrite it. So you're going to take the middle piece and write an inequality with the left side. Take the middle piece, write an inequality with the right side. Now, does anybody recall what you put in the middle? You put and. So what we're going to do now, we're going to go through the steps. Step 1, you're going to solve each part. So I've got -7 less than or equal to 2x plus 1. Okay, so we're just going to solve this like a normal equation. Subtract 1 from both sides. So if I subtract 1 here, I get -8, and then you're left with 2x on this side. Divide by 2. Remember, the only rules you have to remember with inequalities when you're solving, if you multiply or divide by negative, flip the symbol. So there's my first solution set. Let's solve this second part. We've got 2x plus 1 less than or equal to 15. Subtract 1 from both sides. 2x less than or equal to 14. Divide by 2. X is less than or equal to 7. So that was step 1. Step 2 is to plot them on a number line if you want to. So -8, 7. This first solution set, be very careful. This actually is read x is greater than or equal to -8 if you flip it, because you always have to read it from where the variable is at. So if I read this from right to left, x greater than or equal to -8. Closed hole at -8, shaded to the right. X less than or equal to 7, closed hole at 7, shaded to the left. To write your final answer, so let's go to step 3. Step 3 says now go back and look at the symbol that was in between them to begin with. This meant that we joined them with and. So I've got and or this symbol, which means that we find out where they intersect. So notice the only part where they intersect is from here to here. And notice that 8 is included on both, 7 is included on both. So number 4, write your final answer in interval notation. It goes from -8 with bracket to 7 bracket. This solution set just simply means any number from -8 to 7, including them, will work in this inequality. Okay, number 8. Let's go through the steps. Number 1, we're going to solve each part. So let's focus on solving this part first. If we subtract 1 from both sides, we get 3x is greater than 6. Divide by 3, x is greater than 2. if we solve this part, we get negative 3x is greater than 8 when you add 1 to both sides. And then divide by negative 3, so you flip your symbol, and you get negative 8/3. Step 2, plot. If we draw the solution set for 2, it's an open hole at 2, going to the right, greater than 2. And our solution set for negative 1/3 would be an open hole at negative 8/3, going to the left forever. Okay, number 3, we are going to go back and look at what they had in between them, what we're supposed to do with them if we need to find out where they intersect or join them. In this case, you're going to join because I had U, which also means or. So we're trying to find out the numbers that would belong in either set of values. So if you'll look at where we plotted them, the numbers that would belong in either set are all of those from negative infinity up to negative 8/3. It skips this whole area. Then it also includes numbers from 2 on to a positive infinity. So to find out the numbers that belong in either set or to join or marry them, you're going to say it's all the numbers from negative infinity to negative 8/3. We'll put a parenthesis around it because it's open hole. Then you're going to join that piece or solution set with this piece. So we put a U. When it has a gap in the middle, you always put a U. Gap in the middle, put a U, because you're joining this piece with this other piece. So from 2 on to infinity. And that is your final answer. So solve each part, plot each part on the solution, see if you have and or, and write your final answer in interval notation. Okay, I'm going to work 2 more with you. On number 9, this one looks lovely. I know you're excited to work this one. We have this as one entire inequality by itself. And this one. So we're going to find the solution set of this, solution set of that, and finally, where do both solution sets intersect or overlap? Okay, let's use the order of operations, and we need to clear out brackets and parentheses first. So let's look at what's inside. Bring down negative 5. Since we're going to go ahead and clean up what's inside, let's make these brackets become parentheses. And then we have 2 minus 1 is going to create 1. Negative sign distributed to x is negative or minus x, and then greater than or equal to. Let's go ahead and distribute 7. Positive 7 to 2x and negative 3. So that's going to make 25. plus 14x minus 21. Distribute negative 5 on the left side. And then combine like terms. So I'm going to combine 25 minus 21 into 4. Get your variables on both sides. So I'm going to subtract 5x. And you could have also subtracted 4 at the same time, which I probably would have done that. So when I subtract 4, that creates negative 9. And then divide by positive 9. You do not have to flip your symbol here since you're dividing by positive 9. I'm going to go ahead and flip this whole thing around so that I can easily see my solution is x is less than or equal to negative 9. Okay, that was just this piece. So now let's, this piece is going to be really easy to solve, especially after solving all of that. So let's divide by negative 3. You definitely have to flip your symbol here since you are dividing by a negative. So we get negative 2/3. So that was just step 1. Now step 2, let's plot both solutions on the number line. We have negative 9, definitely comes before 2/3 on the number line. We have a shaded in hole at negative 9, and it's talking about everything less than, so it goes to the left forever. Shaded in hole at negative 2/3, and it is also going to the left forever. Okay, now that we plotted them, step number 3 was to go back and look at what was joining them, which was and. So now we need to find out where both solution sets intersect or overlap. Notice that both of them start overlapping here on this side and keep overlapping to negative infinity. So from negative infinity all the way to 9 to negative 9 bracket. And negative 9 was included on both. It was filled in here and it's filled in here.
Did that charger work for you the other day?
What?
Or is it broken? When you buy it, did it work?
No.
Why do you tell me? I had another one.
Sorry. Yeah, that's fine.
I didn't give you another one.
I was so busy. No, I was so busy I didn't think about it. And then I found the extra one I had.
You did?
Yeah.
Okay. I went to plug it in, I was like, I know she didn't use it. And she just gave it back and said, thank you.
I didn't even think about it. Okay, number 10. On this problem, once again, notice that you've got 3 parts. So let's first separate this into 4x minus 1 less than 2x plus 6. Take that middle part, 2x plus 6, and create an inequality with the left side. These type, when you have to separate, always get and in the middle, or this, either one. Solve this part. I'm going to subtract 2x from both sides, and then I'm going to go ahead and add 1 to this side. So I get 2x is less than 7. Divide by 2, x less than 7/2. Let's solve this part. Get your x values together. Let's add x to this side, 3x. I'm going to go ahead and subtract 6. And you get negative 3, divide by 3. X is less than 1, negative 1. plot both solution sets on the number line. Seven halves is 3.5, so, and it's positive, so it definitely comes after -1 on the number line. 7 halves gets an open hole, and it's shaded to the left. -1 gets an open hole as well, and it is shaded to your left also. Trying to find out where they overlap, and the only place they overlap, as you can see, is from negative infinity to -1, but you do not include -1 because it is open on this solution. Okay, hopefully you guys have a better understanding of solving compound inequalities and interval notation. Very lengthy process, but try to follow the steps that I gave you. Take it piece by piece, and try not to let your brain overwhelm you by trying to do it all in your head. I know a lot of you like to work in your head and, not have to do any work on paper, but make sure you're showing me some work on this. But it helps to write it out, sketch a little solution on number line. You don't have to do the number line part, but definitely show me some work on the other. Okay, have a great day.